My sport is indoors. That's a bad thing about indoor sports. They can't get canceled.
All right, so anybody order a calculator last night?
Hey, Mr. Hurry.
Hey, Mr. Hurry, Russell is calling your name.
Russell, wait, you're not bored at you. You have an older sister that plays tennis. You have an older sister that plays tennis.
I don't have a sister. I have 3 older brothers.
She was like you, but like taller and older.
I wonder who.
That's really odd. I actually
We're saying everything y'all both like super ill.
There's a web.
There's like
phone number.
copy paste that shit. I actually thought it was you at first because they were playing like 2 first guys. You came out and you got a
Super face. They might have you hooked up to a laptop.
Super face.
That to USB port, right? Like the charger
Okay.
cable.
It's over.
I was not
And
random.
they might have you download
Two
something.
shades dark, I think it's a Did you see Kenner?
It's gonna be like a dude.
Try that. I've never seen that before though.
Did you see Kenner? Did you see her?
Or you might try it.
She got her face black.
That was bad.
You saw that? Yeah, she sent me that video.
TI-NSPIRE.
She was like
my
going
trick
on
functions or something like that. A lot of times there's a 2-minute video on how to fix
She could
it.
literally pass with it.
But I truly have never seen it. Okay, guys, so if you haven't ordered an Inspire, again, you can do it. I'm going to walk you through that, what to do when you have trig functions that are not sine, cosine, tangent. So it's not overly brutal, but it's something else you got to know. And if you make a little mistake on it, it's going to cost you. Whereas the few people that do have an Inspire, they don't care whether it's sine or tangent or cosine like we did yesterday. Cotangent's not going to bother them. It is the exact same thing. For the rest of you, it's a little different. So let's take a look at a little different. I'm on number 10. All right, so same worksheet we were on yesterday. We're looking at number 10. Cotangent theta is negative 0.3. Now here's the problem. So if you don't have an Inspire, you don't have an inverse cotangent, do you? So if you don't have an inverse cotangent, here's what you can't do. This is the mistake people make. They go, oh, well, here, all I did to solve was go inverse cosine of that. Right? So they think they can go theta equals inverse cotangent of that. Well, guess what? That's true. You can do that when you have an Inspire because the Inspire is an inverse cotangent measure. What you can't do is this. You can't say, oh, because cotangent. Just make a noise.
Just do that. Oh.
He's lost.
Wonder if I could force volume control.
It goes all the way.
If I just. I think that's okay. Okay, this is true. Cotangent of an angle can be found by flipping a tangent. We know that, right? But what is cotangent of an angle?
The reciprocal of tangent.
True, maybe that's a better question. What is cotangent of an angle in terms of x, y, and r? So cotangent of an angle, you're talking about a ratio of 2 sides, right? And I can flip a ratio of 2 sides because tangent's y over x. We know that this is true when I simplify, right? Right? Because 1 divided by y over x is multiplied by reciprocal, x over y. Oh, sorry, x over y. Right? Now, what is inverse trig function of a ratio? I wrote it on the board. It's a what? Inverse cotangent, that's a ratio, isn't it? If cotangent of an angle is a ratio, isn't that represent a ratio of the 2 sides?
Yep.
But if I inverse cotangent the ratio, what am I getting? What does it say I'm getting up here? I'm getting an angle. This is an angle because it says I am an angle, right? Well, here's what people do wrong. When they don't have an inspire, they go, oh, well, if cotangent's equal to 1 over tangent, then inverse cotangent must be the same as 1 over inverse tangent. And they do that. Guess what you just did? You just flipped an angle. Didn't you? It didn't look like you flipped an angle, but what did I warn you about yesterday? You will never take a reciprocal of an angle. You will never go, oh, 30 degrees, 1 over 30. Oh, angle, 7 pi over 3, 3 over 7 pi. You will never take a reciprocal of an angle, ever. I mean, unless somebody goes, hey, what's the reciprocal of this angle? But nobody asks that. It never shows up in trigonometry. You will take a reciprocal of a trig function of an angle because a trig function of an angle is a ratio. And sometimes you want reciprocal ratios, but you never want reciprocal angles. This is a false assumption, but it's so deliciously easy to choose because you say, well, if I can flip a cotangent to a tangent, why can't I flip an inverse cotangent? Well, it's because a cotangent represents a ratio and an inverse cotangent represents an angle. And you can't flip angles because if I flip this, then essentially I have to flip the angle. Bad. So what do you do if you don't have an inspire? Which, by the way, does this wonderfully. If you don't have an inspire, then I can't ever put myself in that situation. I've got to get rid of the cotangent before I go to the inverse. How can I do that?
Can you do 1 over 0.3851?
Well, hold up. We'll get there. But the first thing I'm going to do is get rid of cotangent. So cotangent of theta is, we just wrote it up on the board. A cotangent of an angle has the same ratio as what? 1 over the tangent of the angle. Right? I just wrote that statement, right? The cotangent of an angle, which is x over y, has the same value as 1 over the tangent of it, the same angle, because that's 1 over y over x. And we know that 1 divided by y over x is x over y, right? So what that means is these are interchangeable. So I could say, all right, well, that is the same thing as a 1 over a tangent of a theta. And I'm just literally making a substitution. Now, I still have to solve for theta. So what would you do next if you were in charge right here? You like having tangent of theta on the bottom? I don't. So what can you do to get rid of tangent of theta on the bottom?
Multiply by tangent.
You could multiply both sides by tangent of theta, which would cancel that and leave you 1 equals ugly times tan theta. What else can you do? Like, do y'all know that like when I have a fraction like this, even 3/4, can't I just flip both sides? Right? So what if I flipped both sides and made it tangent theta equals 1 over that? And then just type that in my calculator to get a new decimal to work with. So I'm going to say, all right, so 1 divided by negative 0.3851 gives me 2.59673. Sorry, negative. You with me? And now my problem looks like number 8. Tangent of a theta equals something, right? So right now I basically have tan theta equals negative 2.59673. So now that it's in tangent, what would you do to solve this? And I'm okay with that now, right? Because I have an inverse tangent button. Although what would you do with this value? You're going to leave it negative? Because if I leave it negative, my calculator's probably not going to spit out what?
Positive.
The reference angle. And I need the reference angle, right? Because I have to place that reference angle in the correct quadrants. So I'm going to just make that positive like I've been doing. So positive 2.59673, and that assures me that my calculator will spit out the reference angle. And what is that reference angle when I do inverse tangent of the answer? Oh, and have it in degree limit. If you ever get an odd answer, like I just got 1.2, that doesn't really feel right for a degree. If you ever get something that doesn't feel right, make sure that go check your settings, because normally it means, not always, but normally it means you're in the wrong setting. So I'm going to go back, try that again, 68.9. I'm just going to round to the 10th place. So there's my reference angle. I'm doing the problem just like I did before, right? So where do I find this reference angle? First, second, third, fourth, which quadrants?
Well, normally it would be bottom left, top right, but.
So you mean if it was positive, it'd be bottom left,
Yeah,
top right, so first and third, but it's tangent's angle is negative. And remember, it's tangent, it's reciprocal. So because it has a negative ratio, that could only have occurred when? Second and fourth? Remember the all students take classes, take all, tangent's positive there, so it must, and cotangent's positive there, so it must be negative there. So I'm going to mark an angle in the second and an angle in the fourth, and I'm going to draw the reference angle in there. Remember, the reference angle only goes to the x-axis. So if those are the reference angles, what are the real angles?
I got 111.6.
So my real angles are 180 minus that, which is 111.1, right? Right?
Yeah.
And then the second one that's down there in the fourth would be what?
291.1.
291.1. And then don't forget, because I never limited you, I didn't say that your angles had to be in a certain window. You got to keep adding 360 to these, don't you?
Plus.
So plus 360 and degrees on both. So really, if you had an INSPIRE, you would go like all of this. All you would have had to write on your paper was theta equals inverse cotangent of positive 0.3851, and it would have jumped you right to there.
Okay, I have a question. Why did we take it, since it was a cotangent, why did you do instead of the cotangent instead of tangent boxes? You did all in tangent instead of.
Cotangent is not cosine, right? It's all sine, students, sine and cosecant.
Okay.
Take tangent and cotangent, classes cosine and secant, right? So tangent, the co-problems, I mean, the cotangent, the secant, the cosecant, they just go with their reciprocal. So really this little chart I had for you would be all students take classes. That's just the sine, cosine, and the tangent. And then you just have to remember, oh yeah, reciprocal, reciprocal, reciprocal. Right? Yeah, don't confuse the C with cotangent. That's cosine and secant. Let's try it again. What about number 11? And then I'm going to let you finish up with that tonight, because I know you weren't able to do all those unless you had an INSPIRE. And if you had an INSPIRE, you were able to finish because it was no different. Whether you did or not, that's whatever. So right here, I'm going to get in trouble unless I have an INSPIRE by going inverse cosecant, because I have no way to do it. I have no rules about inverse cosecant. I only have rules of cosecant.
That like B thing doesn't mean anything.
Beta.
It doesn't mean anything.
It means the angle, but it doesn't mean anything special.
But it's the same as theta.
And I don't know why I said solve all values of theta in degrees.
Yeah, that.
I should have said solve for all values of the angle. I'm just switching up the angle variables that I use to make you immune to that. Right? I mentioned that earlier when we we're going over our definitions, that we use theta, beta, alpha, phi, x, y. We can use variables. I normally will use theta, but don't be disturbed by that. That's just an uppercase beta. Okay? Or, no, it's a lowercase beta. All right? Yeah, lowercase beta, lowercase alpha. Most people write their lowercase beta like that, and their lowercase alpha like this. but that's what they really look like. So if that's my angle, what do I have to do first if I don't have an inspire? Change it to sine. So cosecant is 1 over the sine of beta. And again, don't do this. Don't do the sine of 1 over beta. What did you do if you do that? You flip the angle. Don't do that. So I'm going to flip it first and just drop this down. And then I'm going to flip both sides. And then I'm going to type that in my calculator so I have an actual new ratio, simplified ratio to work with. So 1 divided by 4.1783. And I get 0.23933. Now, I know you guys aren't stupid. And I know at least one, but probably more like half to more, are looking at this and going, do I really have to write all these steps? Or can I not take the reciprocal of cosecant, which is sine, and take the reciprocal of that, which is that? Absolutely. You don't have to write all these steps. So if you want, you can just go reciprocal of cosecant is that, reciprocal of that is that, and then you have a problem you can work with. So it doesn't have to be all this writing. Just make sure that you're doing that and getting it to a sine, and then you can begin your process. So how do I get the reference angle of beta? Now I can inverse sine it, and I don't have to change the signs here, which means that the reference angle actually ends up being what? One of the angles. So if you don't change the sign, the reference angle, one of the angles is the same because it ends up being in the first quadrant, as well as other places. So I typed that in my calculator. Inverse sine of the answer. 13.8, we'll call it. Degrees. And where would this angle be located? Since it's cosecant positive. Yeah, sine is in the first and second, and sine and cosecant are reciprocal, so cosecant is positive in the first and second. So what are, if those are the reference angles, what are my actual angles there? So beta 1 is 13.8 degrees, and beta 2 is 166.2, or 180 minus that. And don't forget what? Plus 360n. Yep.
Could you just do like the inverse sine of 1 over that 4.7? Like all of that?
I can do the inverse sine of that.
Yeah.
Yes, because that's what it means. That's the same thing. You're just cutting corners. But guys, listen, if you're one of those who makes careless errors, please be checking your work. I see more ways people screw this up that don't have inspires. Again, having inspires the answer to your problems. You're going to need one. Like my wife and I, we're talking right now about redoing our bathroom. And we're like, should we just wait? Like our house is pretty great, our house, but it's got a dated bathroom in it. We've fixed everything else, redone the kitchen, redone the guest baths, just the master bath, which is the back of the house. Nobody sees it but us, but it's just, we hate it. And I'm like, why are we waiting? If we're going to, why would you if we're going to sell our house at some point, why would we fix it up and then sell the house? Then we don't even get to enjoy it, right? But the house is it's a stain on this house right now. Like if you come over, you're like, oh, this is so nice, and I love your kitchen. I was like, ugh, master bath is horrible, right? You got to fix up the master bath if you're gonna, right? So why wait? So same thing on your calculator. You're gonna have to have one. Now, if your parents have said no, we don't have the money, totally understand. But if you haven't even asked your parents, that's crazy. It can be here on Thursday, and then you can start learning it. You're ready for your test. And you don't have to think about all this junk. You just inverse trig function everything. Just saying. Do what you want to do. Hey, one other thing. Flip over to the other page. Actually, I didn't do it at all. When you get on your homework, more than likely, they're going to give you if it's bookwork, they're going to give you a problem and it's going to say solve, and they're going to give you this. And you're going to see that expression. What does that mean to you? Yeah, you don't have to put the plus 360 in because adding the 360 to angles that are already between 0 and 360 are going to put you too big or too small, aren't they? So in that case, it kind of eliminates the need for those formulas. Remember, the formulas are just finding all the what? Adding 360 in is finding all the other coterminal angles. And if there aren't any other coterminal angles, then you don't need to do that, and there won't be on a limitation like this. And that's normally what they're going to say in your book. But I'm trying to make you better than the book. And we're going to get a little bit deeper in Algebra 2 than Algebra 2 normally gets in this school. So because of that, I want you to be very comfortable with this plus 360n, because when I start doing creative things like instead of beta having 2 beta, or instead of alpha having 1/2 alpha, that changes stuff, and these formulas become very important to you. Okay? So just understand that these formulas writing like this are great when you don't have any limitations. But if you have a limitation, if I gave you this and told me, hey, using these formulas, give me all the angles between 0 and 360, well, clearly 13.8 works, right? But if I add or subtract the 360, I'm outside that interval, aren't I? Well, then you don't need it. Clearly, that's in between 0 and 360. But if I add or subtract the 360, I'm now too big or too small. So I don't need it. Are you with me? Yes? What if I said the interval was 0 to 1,000? Then what would this formula spit out? Well, now 13.8 clearly works, right? Right? But what if I add 360 to it? Is it still in that interval? Yeah, 373.8. What if I add another 360 to it? Is it still in that interval? Yeah, 733.8. What if I add another 360? Is it still in that interval? No. So I would stop there, and then I would just have those 3 coming from this if that interval, if that pertained to this problem. And then I would have to go to this one and do the same thing. And write out all the ones that actually would still fit in there. So those limitations are coming. In fact, they'll probably be on most of your problems, but I want you to get really comfortable with these formulas. And then when the limitations do come, you can use the formulas to find the ones that work. And if there's no limitation, stick with your formula. All right? Okay. All right. Here's what I want to do today. Not a big deal. I don't think, but we'll see. All right, so we're going to be solving right triangles today. The book loves to give right triangles and label them A, B, and C. So this is a standard form. It will always be true for the right triangles that we're going to find. And I don't need this anymore. So let me stop this. Okay, so for the right triangles we're going to deal with, and I'll just start you out. All of your triangles that are right triangles, we're always going to refer to the 90-degree angle as big C. And then the other ones, I normally call this A on the far left down low and that B up there, but it doesn't matter. Doesn't matter. As long as you're consistent, whatever you label A and B, and you did this, I'm sure, in Homer's class, the side opposite A, we're going to call little a. The side opposite angle B, we're going to call little b. And the side opposite angle C, we're going to call little c. That will always be true unless they give you a picture that says otherwise. All right? I think there is one problem in the book where they call that alpha and that beta, but they tell you that. So if they tell you that, great. But otherwise, assume this. That's angle C is always the 90-degree angle. The other two, label what you want to label them, but opposite sides go with those angles. So if that's the case, then all I have to do is give you stuff like this. All right, what if angle A is 22 degrees and side C is 10? Can you solve the triangle? So if you want to draw a picture, draw a picture. All right, so here's me just drawing a picture right here. All right, I know big C is always 90. Little c is 10, so that must be opposite big C. And then pick A or B, it doesn't matter to me. If you want to call this A, that's 22 degrees. Now, to be able to do a problem like this, you've got to know there's 6 pieces of information. There's 3 angles and 3 sides, right? You've got to know any 3. And even though I didn't tell you directly, we know that that's 90, right? So you know 3 of the 6, okay? One of the situations where 3 of the 6 does not help you is if I give you 3 angles. If I give you 3 angles, do you have any idea about the sides? No, because of similarity, right? So that would be the only situation where 3 if something doesn't work. But as long as you've got one side mixed in there, you're good. So I do have one side. So they want you to solve this triangle. So the directions would be solve the triangle, which means I've got little c, I need little a, I need angle b, and I need little b. So little a, little b, angle b, and not necessarily in that order. Anybody got any help for me? Okay, so you know all 3 angles add to 180, and that's a 90. So these two, A and B, always are going to be complements of each other, right? So what is angle B then?
78.
Careful. 68, right? They add to 90. So angle B is 68 because 90 minus 22 is 68. Great, I've got angle B. Now I can use angle B to help me with my other stuff. But keep in mind, if you accidentally, even though I know he knows how to subtract, right? People make careless errors and write 78 accidentally. So if I'm now using angle B and it's wrong, it's going to cause me more pain and suffering. So if it's up to me, if I can use the information that was given to me, I can avoid careless errors probably more easily. Also, for those of you that don't have inspires, why would you use a trig function like cotangent, cosecant, and secant when you're going to write it down that ratio because it looks pretty maybe, but puts you in a bad spot because it's not a calculator button you have. So if you don't have an inspire, you need to think, how can I solve this thing in terms of sine, cosine, and tangent? Now, I need A. I was given 22. So based on 22, what trig function includes opposite or y?
Sine of.
Sine. Now, sine also includes what? The hypotenuse, which is perfect because I know the hypotenuse. I would not want to do this. Tangent of 22 degrees equals A over C. Over B. I would not want to do that, even though it's a true statement, because I don't know B, do I? And I don't know A. So I'm stuck. But sine of 22 works great here because it uses the opposite, the A, over the hypotenuse, the 10. And man, it's pretty easy to solve now, isn't it? What would you do to solve for A? Do what? So you multiply both sides by 10 to cancel it, or slide it over there using the slide rule, right? So if I multiply both sides by 10, I get A equals, and I will have my side A. So according to this, A equals 10, sine 22, and it's 3.7. We're going to round to 2 decimals. So 3.75. And be aware on the rounding. I'll tell you what to round to. She'll be fine. Now, again, I have A, don't I? Now, do you want to use A to help me find the other trig function? Give me 2 reasons why that's a bad idea. Because I could have what? I could be wrong. And also because what? I just rounded. And if I rounded, that rounding is going to hurt me. Now, I do have the exact value of A in my calculator. And even if it only says 3.75 because your calculator rounded, if you highlight that value, and then bring it down, it says 3.7460659341591. It gives you the whole thing. So as long as you're using the exact value, like going second answer and pulling actually the answer down, not the rounded value, you'd be okay. But again, you might be wrong. You might have accidentally hit cosine or something like that. Who knows what? You might be in the wrong mode. I'm not going to use it. So how do I now find B? What trig function? Cosine of 22 uses adjacent over 10. So I'm going to come over here and go cosine 22 is adjacent. Actually, it's adjacent's B, right? So let me just use B, not add. Uses B over 10. And then once again, multiply by 10 on both sides. And you get 10 cosine. What'd you get?
9.27.
10 cosine. Yeah, 9.27. So I never reused a value. Right? I I never reused something that I already found, stayed with the stuff that was given. Now listen, there's gonna come a point where you have to reuse stuff that you found. Not necessarily on this work, but on other work. You'll have to. And when you have to, you have to, whatever. All right, let me give you a different situation. Again, same ABC triangle. I'll leave that up for a second. What if I tell you, all right, A is 12, B is 7, solve the triangle. So if you want to draw a triangle, great. This is always C, so I know angle C is 90. I do not know little c. I do not know angle A. I do not know angle B, but I do know side A is opposite angle A. That's a 12. This is not to scale, clearly. And side B is opposite that. So this is, I'll tell you what, I'll make it scale. Better, to scale. There, that's a little better. Right? So what am I missing? I need angle A, angle B, side C. Anybody got any ideas? Pythagorean theorem works great if I have two sides, always. Unless it's not a right triangle. Y'all do know that, right? Pythagorean theorem, if we want to do something that has non-right triangles, I got to start pulling out stuff like law of cosines and law of sines, which we'll get to. I think you've learned those there. Whatever. So for C, definitely. C squared is A squared plus B squared. So C is the square root of 7 squared. Actually, if I'm doing it correctly, 12 squared plus 7 squared. So whatever 144 and 49, that root 193. I'm guessing that's as good as I can do to clean it up, but whatever. If you want to give me the decimal, awesome. It's a calculator problem, and you want to write, unless it says be exact, which that is exact, you're welcome to write an approximation unless it specifies exact. So this would be approximately 13.89. Now, what about the other ones, A and B? Now keep in mind what I'm given. Which two sides were you given? Opposite and adjacent, which are like my y and my x, opposite adjacent. So what works great for that? Tangent and cotangent. But I'm going to go with tangent because if I don't have a TI-NSPIRE, I don't have a cotangent button. So I know that the tangent of angle A, which I do not know, is equal to the opposite adjacent 12/7. Right? Now, how do I solve those? Oh gosh, that sounds familiar. I've just been solving equations like this, right? Now, let me ask you this question. When I solve for this, I get A equals inverse tangent of 12/7. Now, it's not a decimal like we had yesterday and today early, but it's equal to a decimal if you multiply it out, right? It's equal to 1 point something. You divide 7 into 12. But I can do that on my calculator. So let's just do it, and then let's think about it. Trig inverse tan of 12/7 or 12 divided by 7. I get 59.7 degrees. I'm going to round that angle to just the tenths. So I've got my angle A. And that's rounded, okay? Now, why did I stop there? That's not what I did on my test. I mean, on my homework. On my homework, I said, hey, if I'm solving and it's a positive ratio, where does tangent have a positive ratio?
Top right, bottom left.
Top right, bottom left, first and third. So if that's 59 and that's 59, what are my real angles? Well, 59 and what? 59 plus a 180. So why didn't I do both?
Because it's a triangle.
Because it's a right triangle, right? That one doesn't make sense. We're getting into the realm of sometimes both of them do make sense. Sometimes they don't. I'm going to start giving you non-right triangle situations where I give you information, and there are actually two different pictures that would fit that information. Two different triangles you can make from the same information. And you're like, which one do we use? Well, you have to find both. And how do you find both? Thinking about what you already know. We'll talk about that with law of sines. Law of sines can be nasty, but anyway. So you kind of got lucky in this way because it's a right triangle and you know the angles have to be 0 to 180, right? I'm sorry, 0 to 90, all these angles. So I've got A. How can I find B now? Do I need to do another trig function? Could I? If you did, what would you use to find B if you used a trig function? Because again, if I'm wrong here, guess what happens? If I'm wrong there and I just subtract that from 90, now I'm wrong on both. So what could I do?
Inverse tan 7/12.
To find what?
B.
So you're saying tangent of B is
7/12.
opposite adjacent. So that's this. Now you could use cotangent of B. Cotangent of A is 7/12, but if you don't have a cotangent button, you don't have a cotangent button. So you can totally do this, but I gotta be honest, I'm pretty confident I'm right here. You're pretty confident you're right. Just subtract that from 90. Get your 30.3 and call it a day. All right, but that's what you're gonna get here. If I do inverse tan of 7/12, it's gonna spit out 30.3. But again, if you're not sure, you're a little unsure or whatever, you can always use another trig function. What about, okay, in this homework tonight, and I think you've dealt with this before, they're gonna give you some word problems. And the word problems are a little tricky sometimes. And one of the things that's tricky for people that if I don't explain this is what an angle of elevation or an angle of depression is. Y'all remember those terms? What is an angle of elevation? And I'll give you an example. Like let's just say there's this airplane. And this airplane is flying along. Okay. And in the cockpit, there's this dude or woman, I don't know, whatever, and they're steering, and he's got really good eyesight. And he looks down, and far below, he spots a worm staring at him. Okay? What's the angle of elevation from the worm to the plane? Label it. Where would it be?
The dotted X or X.
That.
I mean Y.
So this alpha, that is my angle of elevation. Because angle of elevation is always measured from a horizontal. So looking at a horizontal, if I elevate my sight, that is the angle that I elevated my sight, but it's always measured from a horizontal. I'm never going to measure it from a vertical. This has no name. I mean, there's a value to it, 90 minus alpha, right? Whatever adds to 90, but it doesn't really have a name. Now, what's angle of depression from the dude in the plane to the worm? Which one's that? I'll help you out. I'm going to draw a vertical, and I'm going to draw a horizontal, and I'm going to call that XY. What is my angle of depression? Which one? Still X. Because angle of depression is also measured from a horizontal. It's the angle that I'm going to depress my eyes or lower my eyes, right? Well, wait a minute. What does that mean if the angle of depression, now, I don't remember much from geometry because I did not learn from the geometry master. Most of you did. So you learned all kinds of geometry. But if there's one thing I remember from poor Miss Wakefield, who struggled, is alternate interior angles are congruent.
Oh, yeah.
Opposite interior angles are congruent. I guess you want to, but I learned it as alternate interior angles, which meant if you have parallel, which you do because I'm measuring from the horizontal, if you have parallel lines and an intersecting line, then alternate, that's an interior angle, that's an interior angle. Alternate interior angles are the same, which makes sense, right? I mean, think about it. If this was 20 and this was a right angle, then this Y would be a 70. And if that also is a right angle, that makes X 20. Those are the same, which makes what?
20.
different spots.
Is
Okay?
that true for everything or just this?
Yeah, because they're all measured from the horizontal. So if I know that the angle of elevation is 20, then I also know the angle of depression is 20. This angle right here, I don't know that that has a name. This angle right here, I don't know that that has a name. Not in my book and not in any book I've read. So anyway, we don't name those, but sometimes I'm giving you angle of depression. It's not even going to be in the triangle we're going to be talking about, is it? So if I give you angle of depression, take it, mark it as the angle of elevation, label up your triangle and go. So how would I ask a question here? I don't know. I might say, if the plane drops a worm snack from 1,000 feet high and it lands directly below, how far is the worm from the worm snack? I'm making crap up, right? So how far does the worm have to dig to surface below the worm snack? Well, it's a right triangle, right? So what do I know? Oh, I would have to know the angle, right? And I said that the angle of depression from the plane to the worm was 40 degrees. Well, that means if that's 40, then this is 40. And if this is 40, that's 50. And I've got one, two, three, 4 pieces of information, don't I? Because I know that's 90 degrees. How do I find how far away he is from his snack? What would you do? Why tangent of 40? Because I have the opposite and I need the adjacent. And what would you do to solve that? Slide rule works great, doesn't it? You can cross multiply and then divide. But if I slide the x up with the tangent, slide the tangent. And by the way, tangent is not like tangent times 40. I can't divide a 40 and then divide a tangent. Tangent by itself is like a log by itself. What's the log? You're like, log of what? What's the tangent? Tangent of what, right? It's just a man-made notation to talk about ratios. So I would divide by that tangent of 40 to put it over here. And I get x equals 1,000 over tan 40, which my guess is pretty close to 1,000. 1,000 divided by tangent of 40 is 1,191. So hopefully that's inches and not feet, or that worm has a long journey ahead of him. He's going to have to burrow 1/5 of a mile, give or take. Right? Be a tough journey from a man and worm. All right, what about this? What time we got? 5 minutes? Y'all feeling okay about this? Would you lie to me? No?
Never.
All right. Some of you are like, maybe. What if I said this? Determine the perimeter of a 10-sided figure. Anybody know the name of that? What? Is it a decagon? Seems like it had a different name. Is it? What's a dodecagon? Is that 12? 12? Again, geometry master. Of a 10-sided figure, if the distance, correct me if I'm using bad wording, from the center of the figure, oh, by the way, of a regular, what does regular mean? Same angles and sides all the way around. So a regular 10-sided figure, if the distance from the center to a vertex, to one of the vertex, a vertex, is 20. Would you be able to do that? Now let's think. 10-sided figure. 1, 2, 3, 4. I'm not going to do the whole thing. 5, right? We got all these sides. There's some center here in the middle, right? Some center there in the middle. So I'm just going to put dot, 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 dot. Now, the center goes out to each edge, doesn't it? And each edge is considered a vertex. So if the center out to each edge is 20, I've got a couple sides, right? Anybody got a guess as to what that angle would be? 360, because if there's 10 sides, there's 10 of these triangles, right? And all of the interior angles on that center have to add to 360. Does that make sense? So each of these would be 36. And if each of these are 36, what do you know about these two? They're the same because this is an isosceles triangle, right? So each of these would be what if that's 36? Let's think about it.
154,
That'd be 144,
Wait.
right? Careful, 144 divided by 2. So each of these would be 72 degrees. Now this is not a right triangle. When you do get right, when you don't have right triangles, but you know log sines and cosines, this is easy. You can just use log sines and cosines. But we don't know that yet in theory. So what could I do to make this a right triangle? Could I split it? And if I split it, what's this 36 become? So that becomes 18 degrees, and I have a right triangle. So here's a blow up of my right triangle. This is 20, this is 72, that's 90, and that's 18. And the question was, what's the perimeter? Can I get there? How? I didn't find that, right?
20x.
What would you do to find that? What trig function?
Adjacent over hypotenuse.
Sine of 18
Wait.
gives me the opposite side over the hypotenuse. That's what I would do. So x equals 20 sine of 18. Are y'all tracking with me? Which is 6.18. What are you going to do with that? And again, I'm rounding, so don't round in your calculator. Take this real calculator answer and go times 10 for the 10 sides. So the perimeter ends up being 61.80 if you were rounding to the tenths, meters, inches, whatever, units. So I might throw you a curveball or two like that, but tonight, do the best you can on this. Definitely check your work. If you don't know why the book's doing what it's doing or explain why it's explaining, please bring those questions in, and let's get you in a good place. Yeah, but I didn't split that length, right? I split this right here, so I was still using that side, right? Because I split it this way. So if I knew that, I would split that side in half, but I didn't. I still used that 20. That make sense? For the answer, what? Oh, my bad. No, you're right. If that's x, that's really just half the side, isn't it? Sorry about that. Is that what you're saying? Okay. So yeah, I need to multiply that by 2 and then times 10. So this ends up being 123.6. Sorry. Yeah, very true, because this really, that whole side is 2x. Sorry about that. I thought you meant that.
Ryan, smarter than
Good call.
Try.
It's my hope. All y'all are smarter than me when it's all over.
Oh, yeah.
You may be now, but I hope you know more than me when it's
Just
all
a
over.
face. Don't worry.
That's my goal every day.
Yes, the calendar.
No.
Your math team, Lynn, we got a hexagon kit. We got a cow.
You done, man?
All right, thank you. I got it. I sent it to you about 10 minutes ago.
Jordan, you done? Okay.